So we're dealing with another 3-hinge arch. This one has a UDL at the right hand side, unlike the first one we did that had the UDL all over the arc. This one has a UDL on one side of the arc at a distance 8 meters from the support B. 8 meters from support B. So simple, the way we have been doing to deal with this, we just to get a reaction, since it is determined by the fact that there are 3 hinges. Just like I told you, the one that has only 2 hinges is not determinate, it's indeterminate. It's indeterminate to 1 degree. The one that has no hinge at all, hingeless, is indeterminate to 3 degrees. This one that has 3 hinges is determinate. So we deal with it as a determinate structure. So to do that, I take moments about reaction B so that I can get reaction A. It's a simple reaction A vertical. I have here 30 times ROA vertical because the distance of ROA vertical from B is 30. Then minus the load. The load is 9 times 8 because that's the coverage of the load. The load, it is 9 kilometer per meter, 9 kilometer per meter, 9 kilometer per meter. To get the whole load, it will be 9 kilonewton times 8 meters to get the whole, since it is 9 kilonewton per 1 meter. So that's why we have the whole load as 9 times 8. Then to get the load as a moment, we multiply by the perpendicular distance from its center of gravity, which is half of the length 8. So that's 4. That's all. That's the computed moment about that point. That is the only 2 roll loads that could generate bending moment at point B as at now. The 2 loads that can, on this structure, that can generate bending moment. So this is equal to 0. So from there we have that ROA vertical is equal to 9 times 8 times 4 over 30. ROA vertical. So ROA vertical gives me 9.6. Equal to 9.6 kilonewtons. 9.6 kilonewtons. So now to get ROB vertical, I take the moment about B and about A. This is about B is equal to 0, about A is equal to 0. So I have 30 ROB vertical because that's the distance from ROA. The next load there is the load itself that will give bending moment at point A, which is minus the load is 9 times 8 times the distance this time will be the distance of the load. Half of the load from the center of gravity of the load is because the load covers the distance of 8 meters, that is 4 is the distance from the center of gravity, plus the remaining length. If you remove 8 from 30, that is 22. 22 plus 4 is 26. Times 26. That is the loads that could generate moment at this time. Half of 8 is 4. Then plus 30 minus 8. 30 minus 8 is 22. That's 26. So it's equal to 0. That means RB vertical will be equal to 9 times 8 times 26 over 30. RB vertical. I got RB vertical to be equal to RB vertical, I got it to be 62.4. It's equal to 62.4 kilonewton. So the next is we're going to get ROA horizontal. To get ROA horizontal, I cut the arc. At point C, I cut the arc at point C. If I cut, I have ROA horizontal. I have ROA vertical. However, that is 9.6 kilonewton. These are the only load there. So I take moment. Total moment about C is equal to 0. About C is equal to 0. So I have 9.6 times the distance. Distance from C is half times 15, that is half of 30. Minus the ROA horizontal. ROA horizontal, the distance from is the rise of the arc, which is 5. which is 5 RA 5. 5 RA horizontal. RA horizontal is equal to 0. So RA horizontal is equal to 9.6 times 15 over 5. RA horizontal. I got RA horizontal. RA horizontal about 28.8 kilonewton. 28.8 kilonewton. RA horizontal has been gotten as 28.8 kilonewton. So the next one to get is RB horizontal. I still cut the arc at point C. At point C, if I cut the arc at point C, I cut the arc at point C. If I cut the arc at point C, I will cut it this way. I have at point C, I have the load. This is the load. The load here, the value is 9 kilonewton per meter. I have RB vertical. RB vertical is 62.4 kilonewton. RB horizontal, that's what I'm looking for. RB horizontal. Simple. As simple as that. I start. So I have the distance of RB horizontal, RB vertical from the vertical location. The horizontal distance of RB vertical from C, horizontal distance, is half of the span, which is 15. That is 15 times 62.4 minus 5 times, because that's the height, 5 times RB horizontal. Then the load minus this way against this and the load minus 9 times 8 times the distance, that is half 4. That is because this is 4 plus subtract 8 from 15. That will give you 7 plus 4. 7 plus 4, that is 11. 7 plus 4 is 11. This is equal to 0. The load, all of them have come in. All the loads required have all come in. All the loads that are there that cost any money. From there, I have that RB horizontal. I got RB horizontal to be equal to RB horizontal to be equal to 28.8 kilonewton. RB 28.8 kilonewton equal to 28.8 kilonewton. That's RB horizontal. So I've gotten all the reactions. So if the next thing I want to take bending moment, anywhere I want to take bending moment, I can take bending moment anywhere I want to take. I want to take bending moment at point 10, for instance, before the hinge. Starting from A, I want to take from point, this I now use RA. That will be moment at, let's say, at point 10. At point 10, M at point 10 from here. M at point 10, that is somewhere here. At point 10, M at point 10. Of course, I will get the rise, because that rise is what I will use to multiply RA horizontal. That rise is, I get it from Y equal to 4F. F is, in this case, is 5 over the span, which is 30 squared. 30 minus the distance I am trying to, the distance 10 minus 10 bracket 10. That is the equation of a parabola, which I will get the rise. So if I do that, I have that this is equal to 9.6, which is RA vertical, which is RA 9.6 times 10. That's the distance, the horizontal distance. The horizontal distance minus the RA horizontal minus 28.8 times the distance. The vertical distance in this case is 4.44. If you do 4.44, if you calculate the rise, 4 times 5 over 30 squared bracket 30 minus 10 times 10. It will give you 4.44. So this is then equal to, this is equal, sorry. That is equal to minus 32 kilonewton meter. Is equal to minus 32 kilonewton meter. That's the bending moment at point 10. So at every point, at point 10 horizontally on the arc, every point you want the bending moment on the arc, you get. So you'll be able to design the arc. The way I just got this now, you have been able to get the reaction A horizontal, reaction A vertical, reaction B horizontal, reaction B vertical. Then bend the moment at any point of the part of it, no matter how the arc is loaded, any part of the arc. And with that, the arc